Hello everyone and welcome once again. Yes, 9 बज गए हैं. Yes. Welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your toast, and always in the ghost mode, Mohit Jain. Today, maybe the last session on this ongoing TCS Ninja series, because from tomorrow, 12th of September, you would be writing this test till 19th of September in different slots. So best wishes to everyone for this. And in this last session, I've picked up few of the questions which were actually asked under the topic like number system. We have SCF, LCM, divisibility format, and few simple questions are asked from this. And we can expect 1 to maximum 2 questions from number system in this examination. So the guidelines are pretty simple. As soon as you see the question, try to pause the session and try to solve it yourself, and then look out for the solutions. So on this note, on this happy note, best wishes to everyone, and do let us know in the comment box once you have written the test that how was the test, whether you have got questions from that particular topic or not, or what if you have got different question, also let us know so that we can help the next slots students, participants, viewers accordingly. So on this note, let's start now. Divya wants to gift a stationery kit which includes a pencil, an eraser, and a sharpener, all one each, to some kids. She went to a wholesaler for purchasing these items. The seller sells pencil in packets of 12, erasers in a packing of 18, and sharpeners in a packing of 10. She purchases the minimum number of packets of pencils, erasers, and sharpeners so that a fixed number of kits can be prepared without any item being unused or short. Minimum number L. We are looking out for LCM of 12, 18, and 10. That's it. 2, 6, 9, 5, and then we have 3, 2, 3, 5. So LCM is 6 into 2, 12 into 15. That is 180. She would be purchasing 180 pieces of each, not the packets, 180 pieces of each. What is the number of packets of pencil purchased by her? The seller sells pencil in packing of 12. That means number of packets of pencils purchased by her is 180 divided by 12, that is 15 packets. She will purchase 180 pieces of each item. That means she would be purchasing 15 packets of pencil. Option C fits in. A yoga instructor wants to arrange students with equal number of students in each row. If he arranges 8, 10, 14 or 16 students in each row, then 4 students are left in each cases. On arranging 12 students in each row, no student is left. What is the least possible value of total number of students? So least possible value of total number of students is such a number that when it is divided by 8, 10, 14 or 16, it will leave remainder 4, and that number is divisible by 12. We can go with the actual classical process, that is we need to find the LCM of 8, 10, 14, 16, and then whatever with the LCM, multiplied it by Q, which is a natural number, and then add 4 to it. And then you can have a check that which number in this format fits in, such that this number is also divisible by 12. But when there is a timer above us, why we need to use this? See, our number when divided by 10 leaves remainder 4. If I deduct 4 from all the option, I'll get 560, 492, 621, 412, and only 560 is a number which is divisible by 10. That means out of the 4 given option, this is the only option which should fit in. And now let's check. Is 564 divisible by 12? For divisibility by 12, it should be divisible by 4 and divisible by 3. Sum of digit is 15. That means it is divisible by 3. Last 2 digit is divisible by 4. That means 564 is divisible by 12. That's it. Since we have a timer on the head, we should try to identify few processes which shall give us correct answer in the given time. Let's take up the next one. In a competitive exam, 5 marks are awarded for each correct answer, and for each wrong answer, 2 marks are deducted. And hence, Arhit scored 32 marks in this examination. If 4 marks have been awarded for each correct answer and 1 marks had been deducted, in that case, Arhit would have scored 34 marks. If he attempted all the questions, how many questions were there in the test? Let the correct answers are with X and wrong answers are with Y number of questions. Then we can have 2 equations and we can solve this simultaneously. Then will we have 5x total marks from the correct answer minus 2 marks deducted, 2y. This is equals his actual score 32. If 4 marks are given for correct and 1 mark is deducted for wrong answer, you would have scored 34. We just need to solve these two to find the value of x and y. Let's multiply this by 2, this is 68. And if I deduct these two, 8x minus 5x would be 3x. These two gone. And this will be 34. That means x is 17. Sorry. 68 minus 32 is 36. That means x is 12. Now 48 minus y is 34. Therefore y equals 48 minus 34. That is 14. Now the question is, how many questions are there in the test? We have got x plus y number of questions in the test. 12 plus 14 is 26. Just to deceive, 12 and 14 are also there in the option because I have seen people marking on 12. Read the question carefully. They have asked how many questions, total questions are there in the test, that is 26, and not only that how many correct answer he have written. He have written 12 correct answer, 14 are the wrong answers, but the total number of question asked is 20. A classical question I should mark this as. The HCF of 180 and 432 is expressed as this. Let's first find the HCF. 180, 432, 2 times. I'm using the classical method to find HCF. That is 360. Then it would be 72, 180, 144, 36, and 72 is divisible by 36. That means HCF of 180 and 432 is 36. Now, they have written 36 as 180m plus 432n. And we know that 36 should be common. This would be 5m plus 712. 12n. 36 is equals to 36 into 5n plus 12n. That is pretty sure that this value should be equals to 1. Then only these two will be same. And it is also given that m and n are integers. Now integers are of 2 types. They can be positive or negative. Now what can be the value of m and n such that the difference between these two is 1? So if I multiply this by 5, I'll get 25. And if I multiply this by 2, I'll get 24. That is the first instance that gives me a hint of getting it 1. And if I subtract these two, I'll get this as 1. That means if I put m equals to 5 and n equals to minus 2, this 5m plus 12n will become 1. and then 36 will be equals to 180m plus 432n, where m is 5 and n is 2. Then what is the difference between m and n? Now they are looking out for the value of m minus n. M minus n would be 5 minus of minus 2, that is 5 plus 2, 7. Do we have this in option? Yes, that is in option B. Now in this question is concept of successive division. We'll see how a question related to successive division need to be approached. A number is to be divided by 1001 and it was divided in succession by 7, 11 and 13 to obtain the remainder 4, 6 and 12 respectively. What would have been the remainder if the number, the actual number, was divided directly by 1001? Now we need that actual number. So to find the smallest of such number, what is this actually? This is the actual number which when divided by 7, leave something as the quotient and leave 4 as the remainder. Now when this quotient is divided by 11, we get some quotient and 6 as the remainder. Now this quotient when divided by 13, we leave some quotient with the remainder 12. To get the smallest of such number, we solve this up backward. And how? Let the smallest quotient here we can get is, that is 1. Then what should be the value of this? That is 13 into 1, 13 plus 12, that is 25. And now you can see, then when 25 is divided by 13, you get quotient 1 and remainder 12. Now move on to the upper level. 11 into 25. 11 into 25 is 275 plus 6 is 281. Done. Now on the higher level what we'll get? 281 into 7 plus 4. Okay, I'm taking the help of my friend. 281 into 7 plus 4 is 1971. So the smallest of such number is 1971, or one of the number is 1971 which we are looking out for. 1971 when divided by 7 leaves remainder 4. 281 when divided by 11 leaves quotient 25, remainder 6. 25 when divided by 13 leaves 1 as the quotient and remainder 12. Now the question is, if 1971 is divided by 1001, what should be the remainder? Remainder would be 970, and that features in option B. Okay, now this is from the divisibility rule. If n is an integer such that 1n352 is a 6-digit number exactly divisible by 24, what is the sum of all possible values of n? Now to have this number divisible by 24, it should be divisible by 8 and it should also be divisible by 3. Rule for 8 is that last 3 digits of the number should be divisible by 8. Now let us check. 352, 32, 32. Yes, 352 is divisible by 8. Now rule for 3 is sum of digits should be divisible by 3. Now what is the sum of digits? 3 plus 1 4 plus 5 9 and 2 is 11. That means sum of digit is 2n plus 11. Now this should be divisible by 3. That means this is multiple of 3. 11, then we can have 12, but then n value would be half. After 12 is 15. 15 minus 11 is 4. That means n value can be equals to 2. Clear? 18, no. N value can be equals to 5. We can just add 3 to it and we can find the all different values of n. We can see, check here. 2 into 5, 10. 10 plus 11 is 21. We can have n equals to 8. 16 plus 21 is 27. But when we add 8 plus 3, 11, that is not possible because n is a single digit number. So possible values of n are 2, 5 and 8. Now the question is, what is the sum of all possible values of n? That would be 2 plus 5 plus 8 and that is 15. Option B Now again an hashtag to this question. Before starting this question, let me introduce to a very simple concept once again. Suppose if we have three number A, B, C, which when divided by a number D leaves remainder R in each case, then how to find this value of D? In this situation, what we'll do, we'll find the three numbers first. And now what will be these three numbers? These three numbers would be A minus B, A minus C, and B minus C. The HCF of these three numbers is actually our D. That's it. If we don't know this concept, we won't be able to move ahead in this question. So this is a simple, short way to find the value of D whenever the remainder in each case is same, but that is also missing. So if this is A, this is B, and this is C, and they are divided by the greatest number D, the remainder in each case is R, then we are supposed to find the value of 3D minus 2R. So first, what is A minus B? 5075 minus 3584, this is 1491. Then A minus C I am doing. 5075 minus 2732 would give 2343. And B minus C, 3584 minus 2732 should give 852. Our job is just to find the HCF of these three numbers. Let me start with the small two numbers, the classical method, which is actually quick method. 852. If I subtract this, I'll get 639. Again 852 will go 1 times 639. This will give 213. 639. This is perfectly divisible by 213. Now let us check whether 2343 is divisible by 213 or not. Yes, it is divisible 11 times. That means HCF of these three number is 213, and this is the value of D. Now what next? We need to find the value of R. Just divide any number by 213. Let's divide 2732 by 213, and it will go 11 times. We know 2343, 2343, and no, it will go 12 times. So let me do it in a proper manner. Once 213 will get 0, 6, 2, twice is 4, 2, 6, then 5, 9, 12, it would be 3, 7, 12 minus 6 is 6, sorry, and 1. So remainder is 176. So value of D is 213 and remainder is 176. They have asked us to find the value of 3D minus 2R. 213 into 3 is 639 minus 176 into 2 will give us 352. 9 minus 2 is 7, 13 minus 5 is 8, and 5 minus 3 is 2. The answer we are looking out for is 287, that is in option C. A classic from SCF LCM again, and we know one single property, that for the given two numbers A and B, product of two numbers is given by their HCF and LCM. And we also know that if HCF of two numbers is H, then the numbers are H into X and H into Y. HCF of two numbers is 17. Let the two numbers are 17A and 17B, or 17X and 17Y, since I have written X and Y. And LCM is 1309. Then which of the following is one of the number? We know that product of the two numbers, that is 17x into 17y, should be equals to HCF into LCM. So 17 gone. If I divide 1309 by 17, obviously it has to be divisible. That would be 77. And 77 is 7 into 11. That means x is 7 and y is 11. The two numbers we are looking out for is 17 into 7 and 17 into 11. Now 70 into 7 is 70 plus 49, 119, and into 11 is 187. And then out of these two, obviously 1 should be there in the option. And we can see 119 is there in the option. Mark on option A, and let's move to the next one. What is the greatest 4-digit number which is divisible by 5, 10, 15, 20? It's a classic question of LCM. We're looking out for LCM of 5, 10, 15, 20 into q times such that it's become the greatest 4-digit number. But why to use this process? We know that out of these all 4 options, these numbers should be divisible by these 4 numbers. That means this number should be divisible by LCM of this. Let's quickly find the LCM. 5, 10, 15, 20. LCM is 60. Yes, LCM is 60. That means these options should be divisible by 60. We have got 0 at the end of all options. Now let us remove this 0. Now it is divisible by 6. That means it is divisible by 2 and 3. It should be an even number. This is not an even number, but these 3 are even number. Done. It should be divisible by 3. The sum of digits should be divisible by 3. 9 plus 9 plus 8. 9, 9, 18 plus 8 is 26, which is not divisible by 3. 9 plus 9 plus 6. 18 plus 6 is 24. It is divisible by 3. And 990, that is also divisible by 3. But out of these two, obviously 996 is bigger than 990. Answer is 9960. Option C fits in. The second digit of a 3-digit number is 1. Welcome to the last question of this Ninja series session, and I picked up a good classical question once again, which can be solved with the concepts, which can be solved with the options. The second digit of a 3-digit number is 1. That means the number is x, 1, y. And the sum of all the 3 digits is 16. That means x plus y plus 1 is 16, x plus y is 15. If the difference between place value of 100 digit and unit digit is 692, suppose the number is like 713, then the place value of this 100 digit is 700 and the place value of this unit digit is 3. That means 700 minus 3 is a value, and this value is given to us. Why I pick up this example? Just to understand that when this number, from this number we are deducting a single digit number, we are getting some value, and we are getting value 692. That means what should be added to this value? A single digit, so that we get a number which is ending with 2 zeros. Obviously 8. If I add 8 to it, what I'll get? 007. And let me check. Yes, 7 plus 8 is also equals to 15. That means my x is 7 and my y is 8. The number I am looking out for is 718. 700 minus 8 is 692 and 7 plus 1 plus 8 is 16. What is the product of all the digits? Product of all the digits is 7 into 1 into 8. That is 56. Mark on option B and move on. If you don't want to think about these things so much, from here itself we can identify with the options. X and Y should both be single digits. Which two single digits should be added so that you get 15? And that is only when you add 7 with 8. Any other single digits when added will not give you 15. Can it? Yes, 9 and 6 can also give. So we need to go back here itself. 7 into 8 is 56, 9 into 6 is 54, but 54 is not there in the option. Or you can play with the options also. 30 is 6 and 5, which is not 15. This is 7 into 8, which gives you total 15. 42 is 6 into 7, which gives you total 13. 72 is 8 into 9, which gives you total 17. Only one of the option is there, which gives total 15. This sum would have been tricky if instead of 72, I would have written 54. Then 7 into 8 is 15. 6 into 9 is also 15. Then we can put in the values 6 and 9 in this place and can check whether we are getting 692 or not. Go in by the concept or play with options, your wish. Best wishes to everyone. Do well.